Okay, exercise 69, a set of problems, and we're doing problem number 14 now. Again, my assumption is that you should read the problem and make some attempt to understand what you've read, write down what, certainly what the unknowns are, and certainly try to answer their question. This is a particularly difficult problem, though, at least I believe it is. All right, so what I want to do is go to the whiteboard and do the problem. And let's do it. And so let me load a screen up, and I think we'll proceed forward by reading, all right, which is probably the best thing you could possibly do. So it says a man ascends the first half of a mountain at a rate 1/2 mile an hour less than his rate during the first half. All right, so what I'm going to do is I'm just going to draw the, this over here, which is the height of the mountain, and I'm going to say that's X miles high. Now, they may tell me what that is later, but right now, I'm going to read that already. He's going up a mountain, right? So the distance is X miles high. So a man ascends the first half, right? So he ascends the first half at a rate 1/2 mile. Oh, let me see. A man ascends the last half. All right, so the first half, I'll write this down, the first half. His rate is Y miles per hour. And the second half, his rate, whoops, I'm a little dizzy here. Let me go backwards and erase that. Second half, his rate, well, again, reading it again says 1/2 hour less. What does that mean? Y minus 1/2 miles per hour. So clearly, just reading the first sentence, it's definitely a distance equals a rate times a time problem. All right? Now again, a man ascends the last half of a mountain at a rate of 1/2 mile an hour less than the rate during the first half. Now they tell me the total time, and by the way, this is the up portion of the problem. The total time is 3 3/5 hours. Now, mixed numbers are fine in conversation, but in mathematics, we prefer to write the improper fraction down. So, that would be what? 18/5. All right? I'm going to keep reading it, and now we're going to talk about the downward part. All right, the downward part. So on the downward part, he still has to go X, by the way. Maybe I should put that down for you. It's still X miles high. But he's going down now. All right? So again, just reading it, and it's not trying to memorize what I've read, but on the descent, he's going down. His rate is 1 mile an hour greater. So his rate is now Y plus 1 miles per hour. All right, let's keep reading it. His rate is 1 mile an hour greater than during the first half of the ascent. So it's Y plus 1. All right. And he accomplishes the time, put this over here, the time now, he does this in 2 2/7 of an hour. And that makes sense. He's going downhill. He's going to do it quicker. And again, we don't like mixed numbers, so it's going to be 16/7. All right, we got troubles now. We got to get a system equation down. I sort of read it, and they want to know what X is in the problem, and I don't know what X is, but I got to write something down, and I'm kind of looking at it. And what I'm going to do is talk about, the time up, and I know it's 3 3/5 hour, but I'm going to talk about the first half. I don't know how much time it took him to take the first half. And I'm just going to say it took 2 hours. And this is the upward part. And the second half, what would that be? Well, it's going to be 18/5 minus T. And this is hours. All right, I got another variable here. There's just too many variables in the problem. I'm going to write something down now. And I want to write the first half down. So what's the distance? Well, the distance is, it's the first half, right? So it's x over 2 equals, well, let's see, what's its rate on the first half? It's y, right? So that's y times t. I'll write that down. Now I want to write this one down too, all right? So he's doing x over 2. That's the second half of the trip up. What's his rate? Well, his rate on the upward thing is going to be y minus, let's see, y minus what? I write it down, 1/2. Put this over here, times the time, and the time is written down for me. It's 18/5 minus t. All right, now what I'm going to do is, you know, I have to write something down. And what I'm going to be writing down, I think I want to solve for t. And let me point out what I mean by that. And let me see if I can get that down for you. Get my highlighter out here. This is probably the easiest thing to get rid of t at this point. And so let me put that down. So over here, whoops, it's got black ink. Over here, it would be, let's see, x, whoops, over 2y is equal to t. All right, so at least I know what t is. I can sort of get rid of that now. And I'm going to plug that over here. And what do you get over here? X over 2 equals y minus 1/2. We're just still on the upward part. And then it's going to be 18/5 minus the t. And the t is x over 2y. Yeah, pretty nasty looking, right? All right, let's do the downward part now. Downward part, a little bit easier, I think. And what is it going to be? It's still a rate times time problem. And let's write this down. So he goes x miles, that's the distance, equals, well, what's its rate? Y plus 1. And how much time does he spend in the downward journey? Well, he spends 16 over 7 hours. All right, I'm going to say what the two equations that I'm looking at now, and let me outline this for you. I'm looking at this one, and I'm looking at this one, and I want to solve it. All right, so let's take a look. I think what I'm going to do is simplify one at a time, and I'm going to simplify this one first, and this would give me 7x equals 16y plus 16. Let me see if I did that right. Multiply both sides by 7, distribute the 16 across. All right, I'm going to do this equation now, and when I do that, you may not, you say, I'm going to do things a little bit differently, and there's many ways to think about the problem. I'm not saying there's only one way to do it. I can multiply both sides by 2. And what do you get over here? 2y minus 1. And I'm going to get a common denominator here. And a common denominator here would be 10y. All right? And what do you get there? Well, I guess I get 36y, right? And again, 5 times 2y is 10y. And 2y times 18 is 36y. Minus 5x. All right? I want to keep moving through the problem. And I want to put on, I'm looking at these two over here. I want to keep working at it, all right? And I'm going to write it down. I'm going to write down 7x equals 16y plus 16. And I'm going to multiply both sides by 10y on the second equation. What do you get? 10xy equals 2y minus 1 times 36y minus 5x. Okay, what am I going to do now? I got to do something. And what I'm going to do is make a substitution now. And certainly, I'm hoping it goes smoothly, but I'm going to now solve this for x. And what do you get over here? 16y plus 16 over 7. I'm going to plug this in over here. So what do you get? 10 times x over 7 times y equals 2y minus 1, 36y minus 5 times 16y plus 16 over 7. All right? So I'm looking at it. I'm going to proceed forward, of course. And what I'm going to do is multiply both sides by 7. Let's do that. 10, 16y plus 16y, 2y minus 1. And as I said, I'm going to multiply by 7, right? Now 7 times 36 minus 35. Oh, I'm sorry. I misspoke there. Let me go backwards. Daydreaming again. If I multiply by 7, what would I get? Minus 5 times 16y plus 16. All right, I'm going to keep going through it, and one step at a time. And it looks like a lot of work, but I'm going to go through it. And what do you get over here? 160 y squared plus 160 y. I'm going to do this slowly but carefully. 2y minus 1. And what do you go over there? 7 times 30, that's 210. And 7 times 6 is 42. So it's going to be 252. Minus 80y minus 80. And again, I'm going to continue to simplify. Let's see, 252 minus 80. Well, let's see, what's that going to give me? Let me get my eraser out. Let's see, 172 minus 80. You know what I'm going to do? I'm going to divide both sides by 2. Just make the number smaller for me. 80y squared plus 80y equals 2y minus 1. And 172 divided by 2 would be what? 86, right? Minus 40. You know what? I can divide by 2 again. Let's do it again. 40y squared plus 40y equals 2y minus 1 equals 43y minus 20. I hope I didn't make any mistakes, but I got to keep going through it. And what do you get over here? 40y squared plus 40y equals, let's see, that would give you 86y squared minus 40y minus 43y plus 20. Well, I certainly have a quadratic. And what do you get? 0, 46y squared. I took care of these two. And this would be minus 80 minus 123y plus 20. All right. At least we got down to something that, I'm going to say is somewhat manageable. Now, certainly when I say it's manageable, you may look at it and say, I can't do that. And I got to try. I mean, what else can I do? I got to try. And, oh boy, it looks like a tough one now, but I'll put this down for you. And let me write this over here. And I'm going to try easy numbers. I got 2y and 23y. That would give you 46, right? And I'm going to try easy numbers. And I'm going to try, let's see, 5. Let's see, 2 times 5. Nah, that's not good. Let's see. I got to think now. I always thinking is tough, right? So 2 times 23. I'm going to go 4 and 5 again. I'll put it over here. Whoops. 5. I did it again. I hate the struggle, but I'm struggling. Now let's take minus. I don't know, maybe it works, maybe it doesn't work. I wish I would factor in. If you don't trial and error, it's always, I wonder if it works. Well, I get 46y squared. I definitely get plus 20 in the end. Do I get the minus 123? Well, let me write this down for you. That would be minus 115. The minus 5 times 23, right? 100. Yeah, 115. And then, let's see, minus 8. Wow, that's minus 123. And that's really good news now. So I have my y, and I'll write it down for you. It's a tough problem, no doubt about it. What's y equal to? And I can't remember what y is in a problem, but we'll get back to that. What's y? Well, y is a number. And I get a number over here. I'll write it down for you. The number would be 5 over 2, or the y would be 4 over 23. Now, I realize for a lot of students, they can't remember what y is in the problem. I'm also guilty of that, by the way. Like when I'm working on algebra, I'm not really thinking about the words anymore. And certainly I hope I wrote it down. And what's y is the rate. So this is miles per hour. So this is one answer. I don't know if it's the right answer, by the way, but that's 2.5 miles per hour. And what's this one going to be? Well, that's really a slowpoke, right? This would be 4 over 23 miles per hour. All right? And then I got to get the x. And so it says, how do you get the x? Well, I got to look around. And I'm going to say this might give me the x over here. 7x, I'll write this down for you, equals, and again, 16y plus 16, right? I'll just write it down this way over here because it's easier for me to do. And I want to figure out the x now. And I'll write this over here, x equals, and I'll write here x equals. And we'll talk about x represents in later. Maybe you can remember, it's really the distance up the mountain. So let's write this down. And let's take a look. You get 7x equals 16. I'm going to do 5 halves first because it's easier for me to do. And 5 halves plus 1, let me write that down for you. 7x, 16. And that's going to get 7 halves, right? And x is going to be equal to, oh, gee, that looks pretty easy, doesn't it? Just the number 8. And what's that going to be? 8 miles. Reasonable. All right, I'm going to do the other one too. Someone says, why do you do that? I don't know. Maybe it works. So you get 7x equals 16. And then what do you get there? 4/23 plus 1. Oh, nightmarish problem, though. Let's put it down. 16, 23. And that would be 4 plus 23, right? And what do you get? 7x, 16. Now it's going to be 27 over 23. That's a nightmare number, isn't it? 16, 27, and 23 times 7. And I'm going to write that down. I don't know if I want to simplify that, but I guess I really should, shouldn't I? Let me do that then. Let's do the bottom. And what's 7 times 23? 140 and 21, 161. And what's the top going to be? 16 times 27, and that's going to be 270. 10 times 27, by the way. 6 times 20 is 120, and 6 times 7 is 42. That's going to be 2, 6, 13, 432. All right, time to think. All right, someone says, why do you need to think? Well, I'm going to look at the easy guy over here, and I want to make sure I understand the problem, right? So I want to see if I can understand this. If this is no good, I'll put an X through it. But I got to be honest with you, these are reasonable rates. 2.5 miles per hour going up is not a bad rate to have, all right? Now, I want to go back to the original, things that I've written down and see if that's even possible. And I got to be honest with you, I'm looking back over this, and it certainly is possible. Like, the trip, the first half, 2.5 miles downhill would be, 2.5 minus half, 2 miles per hour on the second half going up, all right? Now, I want to see if the other one's reasonable, though. This is reasonable, by the way. This is okay. Let's look at this one over here. Now, if it's 4 over 23, let me put this one over here. 4 over 23 is equal to y, right? What would this one be? Well, that'll be 4 over 23 minus 1/2. That's 46, right? And what do you get over there? 8 minus 23. I hope you agree that that's negative. So that's not possible. All right, that's not possible. So this is out of the question. So I have my answer. What's my answer? Well, first of all, what was the question? Let me make sure I understand the question. I have to go back and read the problem again. It says over here, find the distance to the top of the mountain and the rate during the first half of the ascent we got the answer. This is the answer over here. Let's look at the answer key. Now, granted, when I write in the blue area, sometimes when I'm at the whiteboard, I'm not really looking at the blue area. I notice that I wrote something down slightly different, but it's really the same problem. I want to make sure you're looking at the answer over here, and it says, the distance to the top is 8 miles. I got that clearly written down, and the rate in the first half trip is 2.5 miles per hour. Clearly got that written down. There's also a graph over there that indicates the points of intersection for those students willing to look at that to make sense out of visualization of the problem. And we're done. We did okay. All right. Tough problem, no doubt about it. Thank you for paying attention now.